Okay, I'm going to be talking about zeros of polynomials here. A zero of a polynomial is a value of x that would make the polynomial equal 0. So for instance, in the case of this problem, if f of x was to be this, both -5 and 3 are roots or zeros of this polynomial. Reason being, if I stick -5 in for x, this is going to be 25 minus 10 minus 15, 0. Okay? -5 makes this polynomial equal 0. So that's a root. That's a 0 of the polynomial. Okay? If I do 3, that's going to be 3 squared plus 2 times 3 minus 15. Okay? 9 plus 6 minus 15 is 0. Okay? So that is also a 0 of this polynomial. This is a root of this polynomial. Okay? All right, now let's talk about a couple more examples. So we got example 1 here. If f of x equals x minus, I'm going to make it x plus 89, x minus 83, and x plus 55. A, find the zeros. B, or roots. B, find where f of x is greater than 0. C, find where f of x is less than 0. And D, sketch a very vague graph. Okay? So A, the zeros are going to be where x plus 89, x minus 83, and x plus 55 all equal 0. Okay? So I will take this factor and set equal to 0. This factor, set equal to 0. And this factor, set equal to 0. Okay? So subtract my 89. And x equals negative 89. Okay? Add 83. And x equals 83 is another 0. Now subtract 55, and x equals negative 55. Okay, so the zeros are x equals negative 89, negative 55, and 83. Okay, so those are the zeros. Okay, part B and C. Both of them are done together, okay? What I recommend doing is plotting them on a basic number line with open dots. So it doesn't need to be to scale, but I got negative 89, I got 55, and I got 89. Open dots, because these are strict inequality signs. Okay, open dots, hollow circles. Okay, I will label them with region 1, region 2, region 3, and region 4. Okay, and I'm going to use test points. Okay, so we're going to test for positive and negative. Test for positive or negative. Okay? Positive or negative, which would be where it's greater than 0, and this is where it's less than 0. Okay? Because positive numbers are greater than 0, negative numbers are less than 0. So, region 1. How about negative 90? Okay? So I'm going to plug it into the polynomial, factored, negative 90 plus 89, negative 90, I'm sorry, in parentheses, negative 90 minus 83, and negative 90 plus 55. Okay, I'm going to grab a calculator quickly. Okay, I'm back. This is negative 1. This is negative 173. And this is negative 45. Okay? So negative 1 times negative 173 times negative 45 is negative 7785. Okay? Which is less than 0. So region 1 is less than 0. Region 2. How about 0? We'll let x equal 0. I'm sorry, that's supposed to be negative 55. Okay? So over here we got negative 55. So in region 2, we could use anything between negative 89 and negative 55. Okay? So between these two, I could do negative 88, I could do negative 56, I'll do negative 88. So, negative 88 plus 89, negative 88 minus 83, and negative 88 plus 55. So, that's 1. Negative 88 minus 83, negative 171. And this is negative 33. Multiply the three numbers, and we get 5643, which is greater than 0. That means region 2 is also greater than 0. Okay, I'm going to tilt this screen down to make better use of board space. Okay, region 3. 0 is in that region, so we'll use x equals 0. Okay, I want to know if 0 plus 89, 0 minus 83, and 0 plus 55 is positive or negative. Okay, so that's 89, that's negative 83, that's 55. Okay, 89 times negative 83 times 55, negative 406,285. Which is less than 0, so region 3 is less than 0. Okay? And finally, region 4. We'll use 90. Okay? So I want to know if 90 plus 89, 90 minus 83, and 90 plus 55 is positive or negative. So this is 179. This is 7. This is 135. Sorry, 145. So multiply them. 179 times 7 times 145 is 181,685, which is greater than 0, so region 4 is greater than 0. Okay? So I propose to finish C here. Okay? Negative 89, negative 55, 89, open dots, open dots, open dots, region 1, region 2, region 3, and region 4. Okay? So, we determine that region 1 is negative, region 2 is positive, region 3 is negative, and region 4 is positive. So f of x so I'm going to put the answers here. Okay, I'm going to put some answers here. X equals negative 89, negative 55, and 83. Okay, for this one, we're going to be doing two intervals. It's greater than 0 where it's positive. Okay? It is positive between negative 89 and negative 55. So negative 89 and negative 55. So that describes this area. Okay? The other area where it's positive is over here, region 4. Okay, so I'll describe that one. First of all, we're going to do the union to combine the two regions. And then region 4 is 89 to infinity. Okay? It's less than 0 in region 1 and region 3. Region 1 is described as negative infinity to negative 89. Union and then the other one where it's negative is between negative 55 and 89, not including them. Okay, now I'm going to have to clear off some board space. Okay, so I'm going to notice I kept this. Okay, I kept that. So to do D, all we need is a coordinate grid. With that, well, not really a coordinate grid, just a couple of axes. Okay, where this represents X and this represents Y. We need to plot the 3 zeros as x-intercepts, because that's what they are. The curve will cross or touch those 3 values, negative 55 and 89. Now, you must place your curve where on the side of the graph that it should be. Okay, so if it's negative, that means it should be in the negative y's. Okay? It doesn't matter how high or how low you go, just make sure it's on the correct side. Between negative 89 and negative 55, it's positive. So make sure it's on the positive side, but gets back down in time to hit the 55. Okay? Between negative 55 and 89, it's negative. Okay? So have it be on the downside. It really doesn't matter how low or how high you go. Okay? Just make sure it's on the, if it's negative, make sure it's on the downside. If it's positive, make sure it's on the positive side. That's it. You can make these as high as you want. It doesn't matter. Okay? Just make sure that if it's supposed to be negative, it's negative. Where it's supposed to be positive, it's up. And where it's supposed to be negative, it's low. And where it's positive, it's up. Okay? That's it. Okay? Let me do another problem that is similar. All right. Example 2. We'll have f of x equal x cubed minus 14x squared okay, let's see, minus 225x plus 3150. A, find where f of x is less than 0. B, find where f of x is greater than 0, and C, sketch a very vague graph. Now, the problem doesn't specifically say so, but before you can do any of these, you got to find the zeros. Do. Find roots or zeros. Two words that mean the same thing. So we need to solve x cubed minus 14x squared minus 225x plus 3150 equals 0. Okay? I'll take an x squared out of the first two terms, and that gives me x minus 14 over here. If the third term is negative, factor out a negative. These are both divisible by 225. Take my word for it. And that's going to be x. And then 3150 divided by negative 225 is negative 14. These two combine to give me x squared minus 225. And x minus 14, both of them equal 0. Okay, that's the difference of squares. The square root of 225 is 15. So x plus 15, x minus 15, x minus 14 all equal 0. So x plus 15 equals 0. X minus 15 equals 0. And x minus 14 equals 0. Okay, subtract your 15. X equals negative 15. Add your 15. X equals 15. and add your 14, x equals 14. Okay, so those are my zeros. I'm going to put them on a number line. Negative 15, 14, and 15. Region 1, Region 2, Region 3, and Region 4. Okay, well, here goes. I propose that we test the factored version of the polynomial. For positive or negative. Okay? You know, that's good. All right, now, region 1. I propose to let x equals negative 16. Or negative 17, negative 18. It really doesn't matter. Okay? Negative 16 will do fine. So I want to know if negative 16 plus 15, negative 16 minus 15, and negative 16 minus 14, I want to see if it's positive or negative. So that's negative 1, that's negative 31, that's negative 30. Okay? That's going to be negative 930, which is less than 0. So region 1 is less than 0. Okay? Region 2, we'll let x equal 0. Okay? It's in that region. So we will have 0 plus 15, 0 minus 15, 0 minus 14. Well, that's 15. That's negative 15. That's negative 14. And that's going to be 3150. Okay? The reason I knew that was because if I plug 0 into this, all these are going to be 0, leaving me 3150. Okay? You can check it with your calculator if you wish. Region 3. X equals, well, we need something between 14 and 15. Well, there's no integer value, so I will use 14.5. Okay, halfway in between. So I want to know if 14.5 plus 15, 14.5 minus 15, and 14.5 minus 14, I want to know whether it's positive or negative. So that's 29.5, that's negative 0.5, and that's 0.5. And that gave me negative 7.375. Okay? And then region 4. X equals 16. Seems reasonable to me. So I'll plug it in. I'll have 16 plus 15, 16 minus 15, and 16 minus 14. So that's 31, that's 1, and that's 2. That's 62. Okay, and I got negligent on these. Region 2, since this is greater than 0, region 2 is greater than 0. Since this is less than 0, region 3 is less than 0. And since this is greater than 0, region 4 is greater than 0. Okay? So if I update the number line, negative 15, 14, and 15, region 1, region 2, region 3, region 4. Okay? Region 1 is negative. Region 2 is positive, region 3 is negative, and region 4 is positive. Okay? That's going to help me identify which is which. Okay? So the answers for this one and for this one. F of x is negative, is less than 0, where we have negatives. So we're negative here. So negative infinity up to negative 15. That's region 1. Okay? The other one is 14 to 15. Okay? So that is where the function is less than 0. That's where the function is negative. Over here, it's going to be positive, because that's positive. That happens between negative 15 and 14. And from 15 onwards, so 15 to infinity. Okay. Next step, I'm going to do the graph. Or a vague version of the graph. So, doesn't really matter how high your x's and your y's go. The x-intercepts are going to be at the zeros, which happens at negative 15, 14, and 15. Negative 15, 14, and 15. Don't worry about it, making sure it's for scale unless you're provided a grid with the hash marks on it. Okay, now, it's negative before negative 15. So make sure that your graph is on the downside. Okay? It's positive between negative 15 and 14. So make sure, since it's positive between negative 15 and 14, make sure your graph goes up. But it goes back down in time to hit the 14. It doesn't matter how high or low it goes. Okay? Between 14 and 15, it's negative. So make sure it's down but goes back up to hit the 15. And then from 15 onward, it's positive. Okay? And that's it. Okay, hopefully that will suffice.